In this video and in the coming videos, we are going to learn reflection. But before we learn reflection, we need to revise the concepts of the representing point in a plane. Now for that, we need to understand these coordinate axes in detail. Now what are these coordinate axes? Basically, these are used to determine a position of point in a plane by two fixed mutually perpendicular straight lines, which are XOX dash and YOY dash, right? And they intersect each other at O. They are placed perpendicularly at each other. They are the angle that they make over here is 90 degree. Fine. Now the vertical line YOY dash is called the y-axis. We call this as y-axis. This we have done in the previous classes, but we are just revising this. And the horizontal line XOX dash is called the x-axis, right? And O is called the origin. We call O as origin. Fine. Okay. Now, the point, any point that we fix up here, anywhere, will determine its position along x-axis and y-axis. Now, what we do is we fix up a convenient unit of length and starting from the origin as 0, mark off equal distances on x-axis, just as I have done over here. You see, this small box, this is 1 centimeter box, right? So I have considered 1 centimeter to be 1 unit. I have marked off equal distances over here starting from the 0 on both x-axis as well as on y-axis, right? Then the distance measured along OX and OY are taken as positive, while those along OX dash and OY dash are taken as negative, as you can see, right? OX and OY, the distances are taken as positive, and the distances along OX dash and OY dash are taken as negative. You can see this, right? And we call this XOY part. This is a quadrant. There are 4 quadrants. 1, 2, 3, 4. We always started from XOY region. So this becomes our first quadrant. So we call this as first quadrant. In the first quadrant, both X and Y are positive. Then this is called the second quadrant. You don't have to start it according to your own feasibility. The first quadrant remains always XOY. This is the second quadrant. In the second quadrant, X is negative and Y is positive. Then this is the third quadrant. In the third quadrant, both X and Y are negative. And finally, this is the fourth quadrant. In fourth quadrant, X is positive and Y is negative, as you can see, right? Now, how do we represent the coordinates of a point in this plane? Say for example, I have a point P here. So this P is having the coordinates. I have to represent X coordinate first and then Y coordinate. Suppose I am representing a point P as 3 and 4. So X coordinate is 3 and Y coordinate is 4. X has to be represented first, followed by Y. Now here, if you see the position of this point, it is 5 centimeters and 8 centimeters. Sorry, not centimeters. Actually, you can say units right now, because you don't know how much you have kept 1 centimeter over here. You may have your own scale, which we will discuss later. Now, I have 5 as X, 5 units as X, and 1, 2, 3, 4, 5 as X, and 1, 2, this is 8 units as Y. Now, how do you explain this P, 5 and 8? Although your X coordinate is 5 that you know and Y coordinate is 8. right? There's another name for x coordinate. We call x coordinate as abscissa, and y coordinate is called ordinate, right? If sometimes you get in a question that a point P whose abscissa is 5 and ordinate is 8, you have to understand that x coordinate is 5 and y coordinate is 8. Okay, now how do we understand this? How do we define this? P is at a distance of how many units away from y-axis? 5 units away from y-axis. So P is 5 units away from y-axis. And how many units away from x-axis? You can see that 8 units away from x-axis, and P is 8 units away from y-axis, right? Although the x coordinate is 5, y coordinate is 8, but 5 is the distance of P from the y coordinate, y-axis, and 8 is the distance of P from y-axis. Sorry, this x-axis. Right? Let's define it again. P is 5 units away from y-axis and P is 8 units away from x-axis. Is it clear? Although the x coordinate is 5, y coordinate is 8, but P defines, this 5 defines the distance of P from y-axis and 8 defines the distance of P from x-axis, right? So suppose let's take an example. We choose any point here. This is Q. So what are the coordinates of Q? 6 and 3. So 6 and 3. So if I ask you what is the distance of Q from y-axis, you will say it is 6. Although the x coordinate is 6, but this 6 defines the distance of Q from the y-axis. Similarly, the distance of this point Q from x-axis is 3 units, although the y coordinate is 3, but it defines the distance of Q from x-axis. Is this clear? Okay. Then comes the thing like, if we have something like x equal to 0, where will we define this x equal to 0? X equal to 0 means the point will not lie on x-axis. It is 0. It is going to lie somewhere here, anywhere here on the y-axis, right? So x equal to 0, does it mean it is called y-axis? Similarly, if I ask you y equal to 0, define y equal to 0, what is that? So y is 0. There is no point on, there is no position of a point on along y-axis. So all the points, the point will lie anywhere on this line. This is x-axis. So what is y equal to 0? That is x-axis, right? And we also discussed that if we have to define a point, say for example, I have to plot a point 3 and 4. You simply went here and plotted 3 and 4 like we plotted 5 and 8 here. You chose the first quadrant. Why? Because in the first quadrant, x as well as y both are positive. So when you have both the points, these coordinates positive, where will you go? You will go to the first quadrant. Now suppose if I have q equal to minus 3 and 5, where will you go? You will go to the second quadrant, because in the second quadrant x is minus, negative, and y is positive. So when both are negative, where will you go? You will go and plot that point in the third quadrant. Similarly, if you have s as minus 3, so you have x coordinate as positive and y coordinate as negative, you will go to the fourth quadrant to plot this point. Clear? So plotting is clear. Suppose we have to plot this minus 3 and 5, where will I go? I will go to the second quadrant. So minus 3 and 5, this is is minus 3, and 1, 2, 3, 4 and 5. This will be my point Q. Minus 3 and 5. Similarly, if I have to plot minus 7 and minus 2, where will I go? X is minus 7 and y is minus 2. I will go here. So this is my point R, minus 7 and minus 2. Clear? Okay. Now one more thing that we have to understand, that coordinates of origin are always, it's represented by O here, they are always 0 and 0, right? And as we have discussed, the line x equal to 0 is always y-axis, and the line y equal to 0 is always x-axis. And suppose if I tell you that x is equal to 3, what does this mean now? You will go to this point 3. Now x is 3 here. So what you will do is you will draw a line here like this. This represents x equal to 3. Now x equal to 3 is a line which is parallel to y-axis at a distance of 3 units from it, right? So how will you define this x equal to 3? X equal to 3 is a line which is parallel to y-axis and at a distance of 3 units from y-axis. Similarly, if you have to define y equal to minus 2. So y equal to minus 2, you will go here, draw a line like this. So y equal to 2 is a line which is parallel to your x-axis and at a distance of 2 units from it, right? Clear? Okay. So if you have to now represent any point, say for example P as x and 0, where will it be plotted? X and 0. X will have some coordinate and y is 0. So this will lie on x-axis. The point will lie on x-axis. This you have to understand. Then if you have Q as y 0 and y, then the point will lie on y-axis. Fine? Clear? Okay. Now in the next video, we will understand how this will help us to understand the reflection better.